Signal. Okay, well, we're going to go ahead and get started. So I hope everybody's having a good day. A couple things I'm going to run through the housekeeping items very quickly before we go ahead and get to it. First up, the contract. Let me go ahead and get over here. So you're probably tired of listening to me talk about this every day, but if you have not signed that along with your folks and got it turned in, I do need that as soon as possible. Yes, sir. I would have to check. I don't remember off the top of my head, but I've already started looking at people who have and have not. I'm probably going to start talking to folks on Friday because tomorrow I'd like to go ahead and look at College Board and see who's signed up and who's not yet. Okay, but remind me at the end of class so I can check my list. Okay, so does anybody have a contract today that they want to turn in? Hello? ATC? Okay. So no contracts today. Okay. Remember, I do have the digital copy on the website as well as some copies here. So if you need one, oh, got one. All right. Let's pass that up. Thank you. Thank you. Any others? Okay. This is 7th period. Okay. I know you're probably pretty tired of listening to this, but okay, I got to go ahead and go through at least through the first full week. You folks are doing a great job on this, so I want to thank you. Keep it up. Hello. Okay, Scarlett. Would you pass that? Okay. So, be on time. Grab any materials provided on the front bookshelf. So you have a new paper today. Calculators are available. We'll definitely go ahead and make sure that those are up before we leave. And of course, no electronics. So the cell phones, earbuds, and smartwatches. Again, I am really happy with the way you folks are doing that. I'm gonna knock on wood. I have only had one instance where I've had to tell a student to go ahead and put the phone away. So fantastic. I can't thank you enough on that. All right. I did mention the website. So this is pretty important. If you've not logged on to College Board and joined our 7th period Algebra 2 Pre-AP class, 46 WQM3. Please try to get that done as quickly as possible. If not by this weekend, then early next week, because we're shooting for Tuesday of next week, the 26th, to go ahead and have that taken care of. Okay. If you have any trouble, remember I've got instructions on the website, our class website. I got a phone number here, or shoot, just even if you're having trouble, come on in and I'll see if I can help you get logged in, signed up. Let's talk about our class website. This is my goal. Okay, I might have to move a few people. Okay, this is my goal, is to go ahead and every Wednesday have the next week posted. So luckily I was able to get that done today. If you want to go ahead and take a look, that is not going to let me scroll down, but if you take a look, you'll notice we've got the CFA now on Monday, and there's a bunch of other material that we're going to go ahead and start looking at. Okay, what is happening during this class on Friday? We got a fire drill. Okay, so make it quick and short. We're going to go down the stairs, out to the sidewalk on 19th, over to the east side of the building, and you're going to do what? Find the shine. That's exactly right. Find me, because I got to take roll on Crisis Go. All right, so I've got it set up so that today we're going to finish up with our linear inequalities review. There are a few folks I want to go ahead and talk to at the end of class. Tomorrow, I've got a review put together for your CFA. Now, the CFA was originally on Friday, but because of the fire drill, I decided to go ahead and move it. So we're still going to have the review tomorrow, which makes me think that on Friday, we'll go ahead and start, bless you, absolute value functions, and then we'll just continue that into next week. Okay. The only other thing I need to mention, what's on Tuesday? That's the pretest. So the pretest is not for a grade. That's just part of our evaluation system here in Texas. So definitely Monday, Tuesday of next week, please bring your charged Chromebook. Yes, ma'am. Oh, okay. Sorry, I didn't see you. Yeah. Oh, and good news, we have our lanyard. Yay! So we don't have to use the pass. Okay, so I do apologize. That was a lot. Normally the housekeeping items are not going to be that lengthy, but just happens to be one of those days where it is. Are there any questions? We're good to go? All right. Well, if you'll go ahead and do me a favor, pull out the notes from yesterday that looks just like this. Okay. Yes. So if you were absent, I can go ahead and get you another copy of that. In fact, I think I have those over here. There should be one that says second girls. There you go. And you're good to go. Okay. Okay. So if you were absent, I'll have a copy for you. But if you were present, the day that we got the notes, don't have any extra copies for you. I only have enough for everybody to have one. Was there anybody else who was absent? Okay, Yanni? Okay. Would you pass that? Anybody else? Fantastic. Okay. Well, what we got today shouldn't take too long. I want to make it to keep an eye on the time. So we get out of here at 13 after. Okay. So that gives us just enough time to talk about what we need to. So we were talking about how to graph and solve linear inequalities yesterday. And we went through several examples, and everybody seemed to be doing pretty well. Did we want to go ahead and do one to kind of refresh our memory, or do we feel confident? Feel confident? Would anybody like to do one? Okay, don't let peer pressure get you. Because I'm sure everybody in here is like, well, yeah, we want to do math, right? Okay. Okay, so remember, if I go ahead and ask and nobody says anything, I got to believe what? I got to believe you're good to go. Everybody is okay and knows the material, right? Or you just hold your pen. All right, so let's move on. Let's go. So I believe it's going to be the third page that looks just like this. Okay, so compound inequalities. Okay, so bear with me for a second. So I'm going to go ahead and write this out. Okay. So two or more inequalities. So two or more inequalities. Okay. Graphed together on the same number line. Graphed together on the same number line. Okay. So let's go ahead and take a look at this one right here. What we're going to go ahead and start looking at today are what we're referring to as intersections and unions. So when you have inequalities, okay, separated by the word or, we're referring to a union. Okay. You need to go to the notes? You sure? Okay. All right. Now, you go ahead and take a look at each part of the graph individually. So let's imagine that this right side here didn't exist. Okay. So what would this be as an inequality? We're looking for values of x that are what compared to -4. So x is less than or equal to. Now, how do we know it has equality? We have a closed circle. So -4. Now, when you have multiple ones like this, they're joined by the word or. That's our union. Okay. Or now go ahead and give me the inequality for this one. Ooh. Okay. Come on. Well, right now we're working on the notes from yesterday. Yes. I'll explain what that is. Okay, so what was it, folks? X is what? X is greater than 2. Now, why doesn't this one have equality? We have an open circle. That's exactly right. Remember, closed versus open, that dictates whether or not you're going to include the value in your set. Now, when we go ahead and write this as an interval notation, for this first one, if I want everything less than -4 and including, that would be -infinity, comma, -4, bracket. Okay. Somebody tell me, what's the interval notation for x greater than 2? So am I going to start with a parentheses or a bracket? Parentheses. Parentheses what? 2, comma, infinity. Now, if you have multiple interval notations that are part of your solution set that have your answer, this word or, that's the union. Okay. So I'm going to go ahead and say that any value of x that comes out of this interval or this interval is a solution to what I'm working with. Okay. That's what we're doing here. All right. Do the words union and intersection kind of sound familiar mathematically? Some yes, some no. That's okay. That's okay. That's why we're doing this. Okay. All right. So solving OR inequalities. To solve OR inequalities, solve each part, then graph on a number line to show the solutions. Okay. Well, let's go ahead and run through a couple of these. Let's see what you folks think. Okay. So we'll start with number 1. 3x plus 4 is less than or equal to 10, or 5x is greater than 45. Okay, what I'm looking for are values of x that are going to make both true at the same time. Okay, so forget about the fact that, this 5x is greater than 45. We're not there yet. Let's go ahead and just focus on that left one. Hello? Good Lord. Okay. So 3x plus 4 is less than or equal to 10. What would I do? How would I first isolate this 3x? Okay, minus 4. Minus 4. Okay. Opposites are going to cancel, so 3x is now less than or equal to 6. And now what? Okay. Divide through by 3. So what's my first one here? X is what? Less than or equal to 2. Okay. So there's the first part right here. X is less than or equal to 2. Now I'm going to go ahead and solve the other one. Again, just the same skill set. Okay. I've got 5x is greater than 45, but what's the only thing I got to do here? Just divide by 5. So I'm going to have here x is greater than what? 9. So here's the thing. I've either got x is less than or equal to 2, or x is greater than 9. So I want to go ahead and graph these on the same number line. Okay. So let's see here. X is less than or equal to 2. So equality says I'm going to have a closed circle, and then I would shade everything less than that. Okay. What kind of circle on the 9? Okay, that would be open. So here's the 9. We're going to say open. I'm going to go ahead and shade that to the right. And there you go. See, when you're thinking about a union, kind of think about it as a marriage. You're going to go ahead and take all the answers and you're pulling it together into one big solution set. Okay. So for this first one here, x is less than or equal to 2. Would everybody agree the interval notation is negative infinity, comma, 2 bracket? Okay. What's the interval notation for x is greater than 9? Parentheses or bracket? Parentheses, what? 9. Infinity. Now, because I have multiple intervals, we combine them with the U. That stands for our union. So any value of x that I take out of either of those, okay, is going to make that true. Okay. All right. And that's all there is to it. Easy, right? Okay. Now, we're going to go ahead and start skipping around. Like, let's go to number 4. Okay. Number 4. So it says 6 minus 2a is less than 8. Or a over 2 plus 1 is less than negative 2. Okay, so let's go ahead and take a look at each one individually, starting with the left side. Okay, first step. I'd subtract 6. Now, here's the thing. On the first one, I went ahead and showed how I was moving the term over, whether adding or subtracting. Does anybody want me to continue doing that? Does that help anybody? Okay, remember what I said. If you don't say anything, I got to believe what? I got to believe you're okay and good to go. All right. So let's see here. Negative 2a is now less than 8 minus 6, 2. Okay, so now I'm going to go ahead and divide through by that -2. So what am I going to have? A is what? A is what? Greater than -1. What happened? Remember, that's the cardinal idea. If you're working with an inequality and you multiply or divide by a negative, the symbol will reverse itself. Okay, so we'll take care of this one in just a second. Now, the fact that it says A over 2, that's equivalent to just saying 1/2 A. So that helps you a little better to kind of actually see that fraction. No, you can do it like that. So I'm going to go ahead and say +1 is less than -2. Well, think about what we did earlier in the week with a linear function, which is exactly what we're working with here. Okay, how do we get rid of a fraction? Multiply by its denominator. Okay, so I want to get rid of that 1/2, so I'm going to multiply through by 2. So now, help me out. I need 2 times 1/2 A. Just A, because 2 times 1/2 is just 1, right? Now I need 2 times 1, and that's going to be less than what? -4. Okay. So in this case here, when I subtract 2, A is going to be less than what? -6. -4 minus 2. Remember, if it helps you to go ahead and show the term moving to the other side, absolutely go ahead and do it. If you don't feel it is, don't worry. Okay. All right, so I've got A is greater than -1. Okay, so -1 is right here. It's going to be an open circle, and where am I shading? Where am I greater than -1? To the right. So I'll shade this right here. A is less than -6, so we got -6 right here. Again, it's also an open circle, and I'm less than, shift to the left. There we go. That's all there is to it. Okay. Now, take a few seconds, if you haven't already done so, write out the interval notation for me. Let's see if we can all get the same thing. Okay. Is everybody about ready? Okay. Here's what we should be getting. So -infinity to -6 parentheses union parentheses -1 to infinity. Okay, how many folks got that right? Nice. Any questions? Yes. Oh, you mean could we reverse these? So unfortunately, yes, it does matter, because when we write things in mathematics, we always like to go from the smallest to the greatest. Okay, we want to ascend when we're writing these types of things. So if we accidentally reversed it, we would be saying that infinity is smaller than -infinity. Okay. Now I would probably go ahead and just draw arrows to put it back. I wouldn't count it completely wrong, maybe take off a point or two, but I know some professors and teachers who would, the whole thing would be wrong. So, okay. Good question though. All right, what else? Okay. Any other questions? Okay. So here's the thing. Do we feel comfortable enough with the union, or do we want to go ahead and try one more? One more? Okay. And I'll let you folks decide. What looks good? 2, 3, 5, or 6? 6. Ooh, 6 is a good one. I like when we deal with fractions. Okay. Now again, the fact that we have fractions changes nothing. I'm going to do this work over here so I have some more room. This first one, we have 8 minus x over -3 is less than or equal to -5. Okay. So we got a big fraction over on the left. Okay. Let's see. Got it? How do I get rid of that fraction? By what? Okay, -3. So I'm going to go ahead and multiply by -3. So we're going to distribute. So the reason I chose -3, or Yanni told me that, is because those are going to cancel. What I'm left with is 8 minus x. Okay. Now, what are we doing to this inequality? We're multiplying it by what type of number? A negative, so what happens? This is now greater than or equal to positive 15. Okay. Now, if I subtract 8 over, I've got negative x is greater than or equal to 15 minus 8? 7. Okay. Now, is that one completely simplified? Why not? Okay, you want the variable, even something as small as a negative, you're still not done. So let's say I go ahead and just divide through by that -1, but what's about to happen again? You now have x is less than or equal to -7. Okay, and that's very possible. The inequality flipped twice within the same problem. So we've got x is less than or equal to -7. Okay, we'll take care of that in just a second. Now let's do the other one. 5 minus 3/2 x is less than -1. So 5 minus 3/2 x is less than -1. Okay, I know what you're thinking. Mr. West, I got this. Okay. Take a few seconds. Go ahead and simplify that for me. Let's see what we end up with. Okay. Remember, one step at a time, your goal is to get the variable all by itself. We're going to use the opposite operations. All right, so let's see. Just when I simplify this, I'm going to get x is greater than what? 4. That is absolutely correct. Okay, how many folks got that? Okay, anybody want me to run through it? Okay, let's do it. Okay, so what's the first step? What do I do? Got to get rid of that fraction, so what do I do? Multiply by its denominator. I'm going to multiply by 2. Okay, so let's see. 2 times 5, we're looking at 10. Minus, okay. Then what's a 2 times a 3/2 x? It's just 3x. Remember, the whole reason we chose 2 was to eliminate that fraction. And now it's less than what? -2. Okay, so let's see. I'm going to freeze that -3x. I'm going to subtract the 10 over. So -3x is going to be less than, I need a -2 minus 10. -12. And then my final step. Divide by -3. But since we are dividing by a negative, that's why the symbol reverses itself. -12 over -3, there's your +4. Okay. All right, so let's graph it. Here is -7. We have equality, so a darkened circle, and we're going to shade everything left of it. Okay, x is greater than 4. What type of circle? Open. We're going to shade it to the right. Okay, and somebody tell me my interval notation. Parentheses or bracket? So parentheses, remember we're describing this shaded region first. That first inequality. So what? How far below -7 do we go? Okay, so we're going to start with -infinity, comma what? -7, bracket. Now we're about to move on to a second interval, so what do I put between them? Union. Union what? Parentheses. Infinity. There you go. Exactly right. Okay. How are we doing? Easy. Okay. Now that's the union. What was the key word for a union? Or. Okay. Now we're going to switch it up. Let's look at and. Okay. So when you see or, mathematically, that's a union. When you see the word and, this is an intersection. Okay. So let's go ahead and look at each of these individually. It looks like there's only one little shaded segment, but realistically, let's break this apart. Okay. First off, we wanted everything -2 or greater, but we also have everything 5 or less. You've got shadings that are going to be going in the opposite directions. So the word and, the intersection, you're going to be looking for the overlap. Whatever they share, that's going to be your solution. Okay, so I'm going to go ahead and say, like for this first one, x is greater than or equal to -2. And what? What would that other shading be? What's that inequality? See, I did that one. So what's that top one? X is less than 5. Okay. There we go. Now, the thing about this, if you have an intersection and, you'll notice you can absolutely write it separately like that. There's nothing wrong with it, but you can write it as a compound inequality. And what's really nice is your expression is always going to mirror what you've got on your graph. So I can write everything -2 is less than or equal to x, which is less than 5. Okay, because it's saying the exact same thing as what we wrote there. In fact, the interval notation, we've got boundaries between -2 and 5. -2 is included, but the 5 is not. Okay. Any questions on that? So basically, I got a little ahead of myself. What they're talking about here, rewriting the and inequalities. Okay. If I did have x is greater than or equal to -2 and x is less than 5, well, then we would write that as -2 less than or equal to x, which in turn is less than 5. Okay, so if the and inequality is written out, solve each part separately. If condensed, you can solve it together, working from the inside out. Then graph to show all possible solutions. Okay, so we're still solving linear inequalities, so the skill set hasn't changed. It's just that one thing might be a little different here. I'll show you what I mean when we go ahead and get to it. These are separated by the word and, so let's just solve them separately. I've got 2x plus 3 is greater than -9. Let me go ahead and make that a little taller peep here. Walk me through that. How would I isolate x? Okay, so if I subtract 3, 2x is going to be greater than what? Okay, negative. If I could write today, that'd be fantastic. I'm a math teacher. Okay, there we go. -12. -9 minus 3. So now what? Let's divide by 2. Okay, remember, one step at a time. So x is now greater than -6. Now, before you go ahead and start to sketch this on your line, I'm going to caution you, hold off a second. I want to show you something. Okay, we'll go ahead and do this together in just a second. Now let's look at the other one. 8x minus 2 is less than 30. Okay, so let's add 2. So 8x should be less than what? 32. Let's divide through by 8. So what's my expression? X is less than 4. Now, because it's an intersection, it's separated by the word and, we already know it's the overlap. What does each set share is going to become my answer. So what I would do is go ahead and not graph it on the line directly. Graph each one separately, but just off the line. Like, let me show you what I mean. Let's say I'm going to go ahead and graph this first one right here in blue. So x is greater than -6. So at -6, well, wouldn't I have an open circle and I would shade it to the right? Okay. Now let's go ahead and graph the other one. Let me do this one in green. So this one here, I would start with 4, open circle. And where would I shade it? I would shade it to the left. See, now I can put my final shading on the number line because I know exactly where it has to be. Where are the only places where they're directly on top of each other? From -6 to 4. So I'm going to use the same open circles. There we go. That's the intersection. The word and, you're looking for what they share, the overlap. Okay. So now what would that look like as an interval notation? Parentheses, -6, comma, 4. Do I need a union? No, this isn't even a union. I'm only going to have the one interval notation, the one shading region. Now with the union, yeah, I'll have 2. Okay. All right. How are we doing? Anybody having a hard time? Okay. All right, let me go ahead and try another one of these. Let's go ahead and try number 9. Now this one is a little different. They've actually provided this to you as a compound inequality. Now, we could go ahead and solve it exactly as it is, or we have the option, we could break it apart if we wanted to. Okay, so I could go ahead and take the first 2 parts. I could say -2 is less than or equal to a minus 1. That would be the first inequality that I could solve. Then I'll take the last 2 parts. This would be and a minus 1 is less than or equal to 6. We could go ahead and solve it exactly like we did number 7. There's no problems, right? Okay. Now, let's say you're wanting to go ahead and solve it as is. Okay. It's actually super easy to do. All right, so I'm going to go ahead and leave those for just a second. Now, my goal here is to go ahead and get the a in the middle all by itself. Okay. So how am I going to get rid of that -1? I'm going to add 1. Now, here's the thing. When you're dealing with an equation or an inequality, whatever you do to one side, you got to what? You got to do to the other. But I've got 3 parts here. So whatever I do to the middle, I'm going to do to every other part. So if I'm going to add 1 in the middle, okay, what's a -2 plus 1? Okay, -1 is less than or equal to, the 1's cancel. There's my a is less than or equal to, 6 plus 1 is 7. Okay. Bless you. And see, right there, I've already got my answer between the 2 boundaries. So I don't have to do 2 separate graphs. I can just go ahead and shade it. What kind of circle is going on -1? That would be closed. What about the 7? Closed. And just like I want all values of a between these 2, that's exactly how I shade it. You see how the shading mirrors what my expression is telling me? Okay. Now, does anybody want me to break it apart and show that we're going to get the exact same thing? You want me to? Let's do it. Okay. So let me go ahead and do this. So the first one was -2 is less than or equal to a minus 1. And then the other one would be a minus 1 is less than or equal to 6. Okay. All right, well, let's see here. If I add 1, what's my value? What's -2 plus 1? Is that looking familiar? Okay. On the other side, if a minus 1 is less than or equal to 6, again, I would still add 1, but now a is less than or equal to what? Okay. Now, I'm going to go ahead and rewrite this. Remember, I'm a big fan of having the variable on the left. So I would say A is now greater than or equal to -1. Okay? Well, now because these are separate, we're going to graph them separately before I get my final one. I'm just going to use this one because it's here. So -1 has a closed circle, and I want everything bigger than that. We want everything less than 7 or equal to. Okay? So see, isn't that exactly what we got? So if you're working with an intersection, it is completely up to you. You can go ahead and break it apart. You can solve it as is, whatever you'd like. Okay? How we doing? All right. Let's see here. We get out of here in 10 minutes. So why don't we go ahead and do this? Because I am needing to speak to a couple of people. How about, which one do you like? Number 8 or number 10? Number 8? Okay. So here's what I'd like you to do ahead of tomorrow. Before we go ahead and start looking at that review from the CFA on Monday, solve number 8 for me. In fact, with the time you have left, you could probably knock that out in a couple of minutes, not have to worry about anything. Now, this paper that you picked up, this is just extra practice on the lesson that we just did. So if you're wanting a little more practice, there you go. I mean, who wouldn't want to run right home and do some math, right? Appreciate your honesty. There we go. All right. So that's it for today. That's all we got. Folks did a fantastic job. I can't thank you enough. So we're going to do number 8 for tomorrow. Let me